Welcome again, everybody. Thank you for joining us this afternoon. My name is Maria Cruz. I'm a senior open science policy advisor at NVO, the Dutch Research Council, and I will be your host today. This is the third edition of the NVO Open Science in Practice webinar series. In this series, we showcase projects awarded an Open Science Fund grant. Today, we will highlight a project that develops recommendations for the use of fairness metrics for research software. But before I start, we continue with today's program, I would like to just quickly announce the next webinar in the series, which will be held on 15 September on the topic of interoperable open research. We will have two presentations featuring two projects that improve interoperability between datasets in two areas of research. Julian, if you could drop the link to the next webinar in the chat, that would be great. Thank you. So back to today's topic and speaker. It is my pleasure and honor to introduce Lena Lampreff. She is an assistant professor in the software technology group at the Department of Information and Computing Sciences of Utrecht University. And besides being a leader in a research field, our speaker today is truly leading the way when it comes to advancing open science practices in her field and beyond. She's a faculty ambassador of the Open Science Community Utrecht and a member of the science faculty's Open Science team, actively promoting open science practices in the faculty and beyond. And relevant to the project today, Lena has been actively involved in the work towards fair principles for research software since the very beginning. Lena, we are delighted to have you here today to talk about Fairmetrics for fair software. And the floor is yours. I'll stop sharing so you can start sharing your slides, and I'll also mute.
Thanks, Maria, for the introduction, and first of all, of course, also for the invitation to speak here and present the project. And just quickly start sharing here. It worked before, so I hope it works now again. Yeah, Fairmetrics for fair software. So indeed, this is our Open Science Fund project that we were very happy to get awarded. Yeah, I mean, we're still very early into the project. So for those of you who had maybe hoped to learn a lot of our great results, we're not there yet. On the other hand, the good news is that there's a lot of points where you can still contribute your thoughts and ideas that we can maybe then incorporate into the project. But I thought it's also a good opportunity on this topic to talk a bit about the latest steps in the field of fair research software in general, because there have been some advancements in the past month. So this talk is actually going to be about both of that. So on the one hand side, these whole topics of fair for research software, and on the other hand, our project where we want to investigate fair metrics, and fair with not completely capital letters. And yeah, what we think about this and what we mean, I will explain a bit later. It has to do with metrics often being somehow in conflict with open science practices when not done properly. And yeah, the project idea was a bit to see, okay, can we have metrics that help to avoid those pitfalls and still help researchers? But yeah, let's talk about that a little bit later. So first of all, fair principles. So I suspect that meanwhile, most of the people in the audience are somehow familiar with those, but as a brief introduction or refresher, the FAIR principles have been introduced really in 2015-16 with a Nature Scientific Data paper that was called the Fair Guiding Principles for Scientific Data Management and Stewardship. Widely known really as the FAIR data principles, which is somehow a bit ironic because the original paper already talks and emphasizes that the principles should apply to all scholarly digital research objects. Yeah? And these should be findable, accessible, interoperable, and reusable. Yeah, but somehow they got known as the FAIR data principles. I think this has to do with the original the title of the original paper and that it was published in Nature Scientific Data, but also the data, let's say, community has picked up on it more quickly than other fields. And so many of the communication was around data initially. But actually it replies to all kinds of scholarly digital research objects or even research objects, not only the digital ones. So for open science, they are really increasingly recognized as essential for the transition towards achieving a future open science. And this is why they all definitely belong into this seminar series and also into the NWO Open Science Fund. Another way of maybe counting impact is if you look at the Google Scholar citations. And when I looked it up a couple of weeks ago, it was really at like 6,700 citations on Google Scholar and rising. And this, I think, is really amazing for a paper that is like almost, about 5 years or 6 years old by now. And I think there are many other mentions of this paper in like ERC grant policy papers and so on that are not even counted by Google Scholar. So I think the impact that this paper had is really, really amazing. So not only fair data principles. And in this topic, we will talk about software, fair principles for software and for research software in particular. And the first conflict we had in the discussion was somehow that there were people who were saying, no, we don't need separate principles because software is just a special kind of data. And this slide illustrates this a bit where this view comes from. And this view that, software is just a special kind of data is very much I called it here, traditional computer science view. If you look at a computer in a very technical way, then everything in the memory of a computer is represented ultimately as sequences of ones and zeros, which we can call data. And in a computer, information as well as instructions are ultimately sequences of ones and zeros, and so are data. And from that view, you could say, okay, now in software, it's just a special kind of data. So we don't need separate principles because these fair principles for data can just be applied to software. From that perspective, this view may be correct, but we didn't find it very helpful for discussing fair, because I mean, the fair data, fair software, fair whatever discussion doesn't happen on the technical bare metal level of computers. It happens more on a discipline specific or domain specific level of computational science. And there we take a much more abstract view on things. And maybe in the phrasing of the original Fair Principles paper would rather say, no, we're talking about digital objects here, and data are kinds of digital objects, software are kind of digital objects, and there might be many more. Maybe we even should talk about only research objects and not digital objects, but here we get into a much more computational science view on things, and that means there are research objects, digital objects that share certain properties, like, for example, digital objects, we can assign a digital object identifier that they would have in common. But then there are differences between data and software. For example, data are static, while software is dynamic and can be executed. That maybe warrant other or more specialized principles. A bit more on that in a few minutes. I also wanted to mention that in the last years, there has been, fair specializations been discussed for a lot of things, really not only data and software. There's also like maybe code in general, fair computational workflows, machine learning models, microscopy images. There has been work on fair teaching material, but also leaving the world of digital research objects, there's really also work on fair physical samples, of the sharing, the fair hardware, fair batteries. I think Fair Batteries project is also funded by this NWO scheme, and they all share this ideas we can provide metadata that makes these things, research objects, better accessible and findable and interoperable, reusable by people, even if they are not digital. You can still share the metadata and thus make these things fairer. And I don't want to talk more about these things in the presentation, but just to give you an idea what this work is about and what's happening. Specifically for fair for research software, Yeah, the discussion started around 2018 with the first, I remember we had this DTL conference in Utrecht, also with Carlos and Mateus, who I saw in the participants list for today, discussing this. I think we ran a first section, then it was in The Hague at the workshop on sustainable software sustainability. It ran on certain, research software engineering conferences, National eScience Symposium, and so on. And then really quickly kicked off and became more famous. I think this timeline only mentions a few major, I would say, milestones in the discussion. So in 2019, the Netherlands eScience Center launched the recommendations for fair software. We're going to come back to that in a few moments. We had a first paper, a position paper on our thoughts on the FAIR principles for research software in 2020 that was published in Data Science, and I think was in the first half of 2020, the most read paper of that journal, which indeed, again, emphasized the interest in this topic. Around the same time, and also based on this work here, an International Fair for Research Software Working Group formed, jointly convened by the Research Data Alliance, Research Software Alliance, and Force 11. So people interested can follow this link and then even join that. The working group has more than 200 members by now, I think. And one outcome, or the most prominent outcome maybe of this working group, has the recently released official first recommendation for FAIR principles for research software. That has been a RDA request for comments first, and now it's an official RDA recommendation that you can look up behind this DOI if you're interested. So we don't really have time to go through all these principles because it would be a separate talk, but just to give you an idea. So the main argument we make here, software is not data or not just data, because we said, so software is usually the result of a creative process, whereas data is more the results of measurements. And they have data points that you collected somewhere rather than creating them creatively. Software is executable, while data is static. Software is of composite nature. That means that often software builds upon existing libraries and reuses other pieces of software that are assembled. This is, only to a certain extent possible for data as we view it. Software is, subject to frequent changes because, I mean, it's very dynamic. There are updates, there are newer versions of libraries, and so software needs to adapt. That's also not in the same way true for data, and software has a problem of decay if it's not updated. So software needs to be actively maintained to stay usable. And these are only examples of things that really warrant changes to several of the originally data-oriented principles. And just to give you some examples here, for example, findability principle, software is assigned a globally unique and persistent identifier. In a very similar way, exists also as a data principle. There it's only called, I think, data is assigned a globally unique and persistent identifier, a DOI, for example. And this is really one examples of those principles that can be applied to both software and data, and probably a lot of other kinds of digital research objects. But when it comes then to principles around interoperability and reusability, it gets more and more specialized towards software. Some examples given here are, for example, the interoperability principle number 2, that it includes qualified references to other objects. What this means is that there are formal documentations, standardized documentation of the inputs and outputs of the software, for example, or in other principles here, hinting to qualified references to other software. That means the libraries, for example, that are being used in one software, dependencies that needs to be documented in a formal way. And these are things that we don't have in the same style for data. For data, we have something along the same lines or the same thoughts, but still technically different. And so we need a bit specialized, not necessarily different principles. Right, so now the problem that we want to address here, and I think I'm missing a slide here. Let's see. Yeah, I'm missing our fancy project intro slide. Oh, has somehow gone. So I had one nice slide with all the logos and team members of the NVO project. So I'm gonna tell you now. So this is the Fairmetrics for Fair Software project, funded by the NVO Open Science Fund. And team members are, so it's me as PI, Utrecht University, but we have paired up with the Research Software Alliance, represented by Michelle Barker, who's the current director. And we have also members of the Netherlands eScience Center, so Carlos Martinez and Jurian Sparks were on the proposal as well, who have worked on fair software with us before and are also on the project. And we also have been joined by Jonathan de Bruin, who is a research software engineer at Utrecht, the Central ICT, which also has a research software department. So that's the project team. And I'm going to produce a version of the slides to share that has this information. I don't know where it has disappeared. So so the problem that we're addressing in the project is the following. So an observation that we shared in the community of research software engineers is certainly that the application of the FAIR principles to software lags behind their application to data. I mean, this is what I mentioned initially. So the principles have been communicated and perceived for data from the beginning. And there has been a lot of work on that and also a lot of adoption and awareness for that. But this is not in the same way true for software. And there are several reasons for that. One of the reasons that we are picking on for this project is that there's currently a lack of really good metrics. That means evaluated community endorsed metrics to assess software fairness. And also, accordingly, the tooling is also missing, because as long as we don't have the metrics, there will also not be the tools for that. As we will see, there have been suggestions, but they are not in the state that we could call them evaluated community endorsed, that are really, really valuable to assess fairness. But something like that is necessary, because as soon as you want fairness and you want software to be fair, you need some way of assessing, okay, how fair is this thing? And at least two possible situations where you would need this is, on the one hand side, like users who want to choose the fairest option, like the fairest software to use in their own research. For that situation, they would need some way of assessing which software is a fairer one. And and in turn, it's the other hand side. So if you want fairer software to be available to people, you need some way to incentivize their developers to actually make it fairer or make it fair, because it always comes at a price, in the sense that you need to spend some additional effort to make it fair. And then quickly written down scripts may be very like functional, but not necessarily like fair in the sense. And the fairer you want to make it, the more additional work maybe you need to invest, and what would be incentives for people to do that. And of course there can be tools to make that easier, but still this is usually always like a bit of an extra step for people. The long-term vision that we described also in the proposal was that what we want to have in the end is something like actionable metrics and workable tools for assessing the fairness of software, and but which maximize the utility for research software developers and the users, so the researchers, rather than the institutions, the people deciding about promotions, and so on and so forth. And that means, we want them to incentivize cultural change in line with the ideas and ideals of open science. So I think the ultimate counterexample that we always said was, we don't want to create another impact factor or H index, or let's say, so something that is too easy to be misused for other purposes. And then also this incentivization for people would be to only game the system to increase their chances for promotion, which is a fair thing to do from their own perspective, of course, because it's how people behave. If you tell them you're going to be promoted on your fair scores for the software, they're going to do that. But this is not necessarily the right thing to do. And our question here is, okay, how can we arrive at those kinds of metrics? And this is what this project wants to do. So rather than saying we will develop the perfect fair metrics, what we're gonna do is we look at fair software metrics that have been suggested by the community, and there's a lot of work currently going on that, and we will evaluate them with a focus on this potential to incentivize cultural change towards open science. So do they somehow motivate people to make their software fairer? Hopefully intrinsically, without having this push from the outside, so needing it for promotion, but yeah, what can we do? Yeah, towards these aims, we have 4 objectives in this project that also translate into the work packages more or less directly. So we are first identifying candidate metrics based on recent discussions in the community and the literature on that it's available, but many of the works are still like working papers or not formal publications yet. So that is the stage we are at the moment, I have to say. So we have recently started the project, and yeah, when we get to full speed, we will get to the next work packages. So when we have identified then the metrics that are potentially automatically accessible by computational tools, we will implement prototypical tooling for applying these metrics to software projects, and then apply them to selected research projects from different areas to get feedback for this and talk to the developers. And then finally, we're going to aggregate these findings that we have into recommendations for fair software metrics and toolings. So this is the outline of the project. So what we have been doing now is really to start our survey of what we call then candidate metrics. And yeah, I'm picking 2 of them for this presentation today that are somehow like 2 extremes, you could say. And this list indicates just a few other things that we have on the list. If you look at the list now and say, no, I know of other works that is missing here, we would be very grateful to learn about that. Maybe drop something in the chat or drop us an email later on. But these already might give you an idea of what we're talking about. So the first one is these 5 recommendations for fair software from the Netherlands eScience Center that I already mentioned in the beginning. And there's a corresponding tool also with that is already existing called How Fair Is. So this is one thing. Another, a bit of the other end on the complexity spectrum, you could say, is a fair soft approach proposed by a group at the Barcelona Supercomputing Center. I'm going to talk a bit about that. And then I just want to include a link here to the working document of the Fair for RS metrics working group that has also started to think about fair software metrics. That is also one source of input that we're going to follow. But in this presentation, I'm only talking about the first 2 of this list to give you an idea and an example of what possible metrics could be. So fairsoftware.nl, or the same website is also available at fairsoftware.eu. I kind of assume or hope that many of you have already visited this site at some point during your work. So this has been launched in 2019 at the National eScience Symposium, since this has been available. And it's a fairly really nice and useful website that gives you 5 very practical and concrete recommendations for making your software fairer. And so these 5 recommendations in brief are here listed on the left, where the first is just use a publicly accessible repository with version control. GitHub, for example, that would be the main candidate. Add a license so that people know under which conditions they can use your software or not. Then third, register your code in a community registry, because this is where members of scientific communities go to look for software for their problems. So make sure you are represented there. Then enable citation of the software so that people can give credit to the software directly. And that is actually possible. So it's not, even if there's not a specific traditional paper around the software, there are formats and citation formats available where people can directly cite software. So enable that, provide that information so that people can do it to directly get credit for the software when people use it. They will not always cite your paper, but they can cite your software directly. Yeah, the fifth recommendation is to use a software quality checklist. Well, and if you go to this website, I mean, it gives further information on all these points, on different very accessible repositories like GitHub, about different licenses to choose, relevant community registries, software quality checklists for all kinds of languages and communities. So this is really, a good starting point if you want to go that way, and very practical. Now, and what this How Fair Is tool does is, to analyze GitHub or GitLab repositories, so GitLab repository for compliance with these 5 recommendations. And it's simply like a binary assessment of these, so yes or no. Yeah, so first one, is the code in a repository? Yes or no. Is there a license information? Yes or no. Is the software in a community registry? Yes or no. Is there citation information, and has a software quality checklist been used? And I took here a screenshot from the How Fair Is page itself. So it applied its own recommendations, showing here, the code is in a repository, there's a link, it has a license, it's registered. It's this Python code, so it's registered as a Python package in the PyPy index. There's citation information, so a DOI minted by Zenodo that points to a version of the software. And software quality checklist has been used, the OpenSSF best practices. Now you can see even here, although this has not been like fulfilled by 100%, it still counts as has been used. There might be reasons for not hitting 100% here, but at least like developers show that they have been paying attention to this checklist. Well, what How Fair Is then does as well, so it just counts up these individual points and sums them up so that you can get a How Fair Is badge, with a maximum of 5 points here, and then you can showcase this on your GitHub repository, showing that you comply with these 5 recommendations. So this is the How Fair Is tool. We also use this in another project at Utrecht University that's currently running. So we call that SWORDS, for Scan and Review of Open Research Data and Software at Utrecht University. This is a project that we started internally about 1.5 years ago, because we wanted to find out more about how our researchers develop and manage software, with the initial motivation to learn more about where they need additional support, training, information to make that better. Because we have the ICT services and research engineers that are ready there to help people and develop trainings and offer everything, but it was not really clear what people actually need. And so we started this project to find out more about the current situation of data and software, open data and software at the university. And it includes many other different dimensions, also on licensing and so on and so forth. But we also ran the How Fair Is tool on our data. And as of last summer, we have ran it again recently, but the situation has not changed significantly. So this data is still okay. So we had identified 143 GitHub users from the universities to combined almost 1,400 repositories. And we ran this analysis, including the How Fair Is score. And what this graph shows here, that many, most of the projects actually get a How Fair Is score of only 1 or 2, where kind of 1 is trivial, or at least 1 is easy to get because we started with GitHub repository. So they are the first principle of being available in a repository is of course true. Then again, many projects have fulfill 1/2 of the criterion. Often this is the license information, and then but projects that have a How Fair Is score or badge of 3 or higher really are rare. But what we did internally, and that was interesting, we give a similar presentation about sorts internally, and there we had a list of the projects who scored 4 or 5, and especially those who scored 4 and not yet the 5, they really immediately after the talk they started questioning us what they could do to improve their score. So this is maybe an indication that this like badging and scoring can already motivate people, and a lot of the people here of course did not know about this, about how fair is. If we would tell them, maybe they would also spend more attention. And another thing is sometimes how fair is just not able to spot that people have been doing particular things. Yeah? So for example, if someone registered their tool in a community registry, but the GitHub page does not have that information, then how fair is will not easily find, or may just overlook that. So the fairness scores of our projects here might be better than the scores suggest. But still, it's an interesting indication, I think, from the experience we had. These kind of badging approach based on 5 simple criteria might really help to motivate people. But this is only an assumption or indication at the moment. Maybe we need more. So another approach to this software metrics problem has been proposed by Eva Martin del Pico and the members of her group in Barcelona Supercomputing Center, and they call it FairSoft. So the first preprint is available here on bioRxiv a couple of weeks ago, and they call it a practical implementation of fair principles for research software. And one thing you will immediately recognize if you look at the paper is that they really take the suggested fair for research software principles, which are many more than this 5. So the fairsoftware.nl approach, the 5 recommendations were really 5 practical recommendations, which are, however, not directly aligned also with the fair principles for research software as suggested by the working group, which is completely fine. It's just a completely different approach at defining metrics. And so this group has started more from the list of adapted fair principles from the fair for research software work, and then started to turn that into measurable indicators. And what they do then is they apply a scoring system or define a scoring system to weigh the different indicators to finally then offer a kind of like quantitative assessment of software fairness when applied to some tool. I mean, a bit more concretely. So if you look at the, and this is taken from their paper just to show you. So they have this table of fair for research software principles, which are not exactly, but very much in line with the principle as suggested by the Fair for RS working group. And the principles would always be here. So F1, F2, F3, and so forth. And these corresponds also kind of to high level indicators. And then what they list below, it's always a list of so-called like low level indicators, rather like almost like examples of what these criteria could be, so that that this criteria gets partially fulfilled, or what options for these are. I don't want to go through all of them, but just looking at some example could be, for example, one of the principles and high level indicators is that the software can be found online, and low level indicators for this would be that it's included in one of the main software registries, and that it can be in one of the major software repositories, or in one of the literature services, for example. These are like indicators, low level indicators for this, higher level indicators for fairness that the software can be found. And then the idea is to with certain weights, but to summarize these things in a score. So the scoring system of FairSoft assigns weights to low-level indicators, corresponding to their relative relevance for high-level indicators. And of course, I mean, I took an example here again from the paper and adapted it a bit just to show the idea. So for for the identity uniqueness, for example, there are two low-level indicators, uniqueness of name and identifiability of the version. And we say, okay, for this, the relative importance of this, the uniqueness of the name is more important than the version identifiability. Yeah, and similar here for metadata and for the searchability examples that we had before. So these always sum up to 1 for the relative importance within this one high-level indicator, and then the high-level indicators for the overall principle of findability are again assigned weights, and they sum up to 1. And then you can see, okay, this results ultimately in a score between 0 and 1 for each of the FAIR principles. So you can do this for individual tools, but what the group has done in particular is to apply this FAIRsoft approach to a really large collection of life science tools, and more than 40,000 actually, that are mostly bioinformatics tools run or known by the Open eBench platform. So Open eBench is a big benchmarking platform that, among other things, monitors available bioinformatics tools. And yeah, it is possible also to kind of sneak this FAIRsoft tool in there and let the Open eBench assess software fairness based on these criteria. And what they have done on these 43 tools is really ran that approach to that. And this kind of graphic summarizes the fairness level of the whole collection, not of an individual tool, but of the whole 43,000 or 44,000 tools almost. And what you can see here by the plots, I hope it's more somehow readable on your screens as well, is that in general, the patterns seem to be that the tools do pretty well on findability, because you have most of the tools getting quite high scores here. There's also accessibility is also quite good for a lot of tools, but although there are some which is not so amazing or not so accessible. And yeah, for interoperability and reusability, the picture is very mixed. But this is completely in line with the experiences that we have, that the interoperability and reusability are also more difficult to define. And also, it's also sometimes not so clear what to do for achieving these principles for software. So this needs to be interpreted. Yeah, these only as two ideas, like what people have suggested to do as for measuring software fairness. And yeah, what we will do next in the project is finish this review of suggested metrics. It's a bit difficult because there's always new stuff coming up, but we hope to reach kind of a fixed point on that soon, so that we at least can make a selection of the metrics that we want to discuss. Implement tooling is a practical step so that we can actually run this on research software projects. We plan to apply that to, we said at least 100 open source research projects on GitHub. We have a quite good collection based on the source work already. We will look at the eScience Center software directory to find more, but also here's a chance. So if you want to get included and interviewed about like metrics and contribute to this work and want to make sure that your project is included, drop us a note and we'll be happy to put you on the list. And then the big thing is really to evaluate the effects on the developers. So to interview the people and ask them, okay, what do these metrics now mean for you? If you get how fair is badge of 4, what will this do? When you get a FAIRsoft score of that and that, what will you do? And what can this metrics? And then we will formulate these recommendations of what is useful. And yeah, as I said, the motivation of this project is really to focus on not only what are accurate metrics, but what is useful to foster cultural change, in the sense that people feel incentivized to make their software fairer. And points to consider that we have is, okay, what are actually incentives for research software developers? And that probably differs between like who is a developer. Is it like a research engineer, or is it a postdoc researcher who might be evaluated also on the job for different things? Is it more useful to have quantitative or qualitative assessment and feedback. It's scores, badges, other forms of summary, or rather going very detailed. What would be useful? So these are things that we are going to focus on. Again, if people have other ideas and suggestions, we are more than happy to hear them. Yeah, I think I'm coming to the end of this presentation, though we have still a bit of time for discussion. So the points I would like you to remember and take away from this is really to remember that FAIR in general is essential for the transition towards open science. It has applications not only to software, but also to other kinds of research objects, and they all kinds of need a bit of like specialized FAIR principles, always along the same lines, but yeah, they always need to be adapted a bit. Various metrics have been suggested, not only for software fairness, but for fairness in general. But they should not just be applied without thinking about this. So what really is missing is an evaluation. And on this project focuses on the incentivization potential in line with open science principles, so that we can hopefully in the future have metrics and tools implementing these metrics that really help researchers and help fostering cultural change towards open science. And with that, I'm at the end of the presentation. I will, for the moment, stop sharing my screen so that I can see and hear you back. Yeah, and I'm happy to see if there are any questions, suggestions, points, whatever. I think Maria wanted to help moderating.
Yeah, thanks very much for the wonderful presentation, Anna-Lena. There's already some questions. Oh, thanks, Egon. Yes, I wonder, I think I'll allow people to unmute themselves.
Yeah, sure.
And start the video. There's not, it's a manageable sized audience. Egon, if you'd like to ask the questions directly, you're welcome to unmute. Yeah, hello.
Hi. Hi.
Hi.
It's very interesting. I'm very eager to apply this. I have two practical questions.
Yes.
The first one is the metrics that you have developed. Are those available in the machine readable format that Mark Wilkinson developed? So as a combination of Markdown and nano publication, I think.
We have not developed the metrics. We're looking at what people have suggested, right? So I would need to defer that question to those people. I'm really not completely sure, but I don't think so.
Okay. Oh, we can follow up on that.
Yeah.
I'll go ahead with the other question. So actually last weekend I spoke with someone telling me about the GitHub Utrecht University repository and all the work being done to get that together. And I'm actually quite delighted to see that mentioned here.
Yeah.
You analyzed a lot of that. How can we scale that up? So basically, one thing that has intrigued me from all the Dutch open science is that we don't have a central place. We don't have a Dutch registry, if you like. So have you been thinking about something like either a Dutch national registry for all the software or the open science software in the Netherlands, or for the NVO open science grant system?
Yeah, for the NVO, so that is more a question to Maria. So for sorts, I could say, it has really been a project that started internally, but I have now also a master student who's trying to scale it up and describing this process in a more general way, because it was really like a hands-on to get a quick idea of what you have at the university, and he's now his thesis is on how to frame that as a more general process and method, how to do that, and he's facing exactly that problem. So how do you get together all the scattered GitHub profiles of people? And this is really a problem because we don't even have the GitHub names of people at the university. So data that we have at the moment is always incomplete. I think it's still useful for the purpose that we have for kind of, if you want to see what kind of training material you should provide, it still gives you a good idea. That's fine, but it's far from complete. And but that's maybe more like overarching question. I could make suggestions from my own researcher's perspective, but it would perhaps be helpful if NVO had a software registry for all its funded projects, or if Dutch researchers would always be kind of now, forced is maybe too much, but like incentivized again to register their stuff as a big research software directory instance run by the eScience Center, these kind of things. Because at the moment, the really practical problem is really, if I just want to know which GitHub repository at my own department, it's really difficult to do. I mean, there's not a central place. Utrecht University started to enable people to put their GitHub handle on their profile pages, but only a fraction of people does. So, and many others have profiles, and then maybe they don't use their real name, and they don't have an indication that they're at Utrecht, and you discover that they actually have a profile much later. So this is practically a bit, can be very difficult in practice.
Yeah. Some years ago, we started actually a Google Drive spreadsheet. I will try to share that with you later, but I'm pretty sure that is already very incomplete, but it focused on the institute level repository/organizations.
Yeah. I think it's always probably you can have a snapshot in time and be very, very complete, but then it's so dynamic, and people are starting new projects, especially small ones. It's really difficult to capture.
I saw a hand raised by Carlos Martinez, and I was wondering if I was reacting to that, because I know the eScience Center have a software registry, and it's a great recommendation, something for us at NVO to think about. But perhaps, Carlos, you wanted to react to that?
I wanted to, which actually now Marian is also pointing to the research software directory. So at the moment we have the research software directory from the eScience Center. Basically, that's what it does. It just points to different software, but at the moment it's only used for software that is developed at the eScience Center. The software itself is actually usually hosted at GitHub or GitLab instances of project partners, but basically the research software directory concentrates all this information from all the different GitHub repositories. And we are at the moment building a version of the research software directory that it can be provided as a service, so that other organizations can basically add their own software to the research software directory, and then you can have basically like a national. You could create like a national registry where every organization has their own corner, but that you could have research software indexed from many different domains. So that's something that would be that it's sort of on the roadmap for the research software directory. It would be possible to have this, and I would really love to see our research software directory growing into something that could be like a national directory for all open source software.
I think, but you would still have the challenge of really having capture all, because that doesn't happen automatically.
No, so that's
always dangerous to claim.
Yeah, so that has been the challenge. We've had several pilots with the Utrecht University Digital Humanities Lab and with another group at the UVA, and the most challenging part of it is like the curation of the data, right? Because you have to add data and add all the metadata and make sure that all the metadata is updated, and if there's a new developer working on the project, you have to add them. And curation, it's a full-time job. So there has to be someone who's taking this into account. And I think, suppose if at some point there's credit for people who do this type of job, and you say, well, yes, and you are credited as a researcher for adding your software in the research software directory, then that gives an incentive for people to do the curation. So that's the challenging part. So that's all I wanted to add. Thank you.
Thanks, Carlos. I'll move to another question. And by the way, so I'm calling people to ask their own questions, but obviously you'll be recorded. So if you prefer not to be recorded, just let me know through the chat. But we had a question here from Naeem. Would you be comfortable to ask that question yourself? Would you be comfortable?
Yes. Yeah, just a second, please. Hello, can you hear me?
Yes, we can hear you. Thank you.
Yeah, well, thank you for such a nice presentation. My question actually is more about open science, open source software development and FAIR principles that you are actually working on for softwares. So they seem to have some common grounds. Actually, there are some principles that are pretty common in both. So is there something actually you had to consider that is not applicable to the closed software, but only to the open software development, or other way around?
No, I mean, yeah, it has been a long discussion in the on the work towards the FAIR software recommendations, actually. Yeah? So should the FAIR software principles require the software to be open source or not? Yeah, so should that be a requirement or not? Because for the data principles, it is not. And this is, I mean, if you look at data management, that's also perfectly sensible because there's sensitive data and you cannot require data in general to be open. Yeah, so, and you could make the argument that that's not true for software in the same way, because I mean, patient data can be sensitive, but the software analyzing the data typically is not. So maybe it should be made open. But then in the, finally the argument was, so the FAIR, as you said, so they share some intentions and common grounds, but then FAIR does not require things, data to be open, like the content to be open, right? What FAIR requires it is open metadata, so that everyone knows that a certain piece of data or then also software exists. And that you can find information about that, but the access to the thing itself, whether the object, the data, the software, the workflow, the physical sample, whatever, that might be closed or restricted. So what FAIR requires is that the access conditions are clear. So something that, I mean, you have seen in papers for many decades, I think, like software available on reasonable request or something, that would be not sufficient. Yeah, so the FAIR would need to state, okay, it's maybe only available for academic use under these conditions, but if you provide that in the data or if you register, then you will get access to the software. That would be fair. So this is, it has been really a long discussion, but what is now in the FAIR principles is that the license need to be clear. It's that is then fair. And I think there's the community, there's a lot of support for open software, but it's not a requirement. Like a license or clear access conditions are required for FAIR, but not necessarily that it is open. I think that maybe not necessarily everyone in the working group was happy with that, but I think that's a compromise.
One more brief question, actually. Coming with some FAIR principle for software, does it actually has any implication on the fairness in the data itself, which is not software itself, that you will only say data is fair if it has been actually generated or processed by a software that has that degree of fairness? But that's not the intention, I guess, no?
I mean, you could do that, and maybe you can make a case that that is like desirable to do that you not only use fair data software, but also fair data. But I think there's also different ways to generate data in this. So I think that's a bit difficult to make. But of course, like if all your process is fair, I mean, you could start by fair and open lab notebooks and fair software and fair data and have your whatever machine learning models fair. I mean, you could do that the whole long way, but I think it should not be a requirement. Also, if you think of software, for example, that was one discussion point as well. So should fair software only build based on other pieces of fair software, like fair libraries and stuff? Exactly. But then it would be kind of desirable, but you would also limit people very much or punish people. You cannot make your software fair because the libraries are not available in a fair way, but there's no alternative. So this does not seem very realistic.
No, it's not inclusive, as a matter of fact.
Exactly. Yeah.
Thank you. We only have 5 minutes left, so I'll read. Well, I don't think we'll have time for all the questions, and apologies for that. I'll read one of the last questions that came in. Can software that requires a proprietary kernel to run, for example, Matlab, Mathematica, Maple, etc., ever be considered fair?
It's again one of these tricky questions, right? In principle, you would say yes if it's clearly documented what the conditions are. And you wouldn't punish the software itself for running on it, because you could maybe share the Matlab code and do that in a fair way. But I mean, if you're clear about, okay, but to run it, you need to have a Matlab installation. I think it would be like fair, but I mean, it's maybe not the best solution in the sense of open science. That would maybe be my answer, right? So, and that's again the point, like they share a lot of like ideas and visions, but they are really not the same thing.
Thanks. I'll read one.
But licensing
more.
Is super tricky.
I'll read one more. I think we'll have time. There's one here. So I'm not familiar with FAIR in software. With interoperability is meant in the sense that whatever language used, that piece of software can be integrated in another script using a different language. So it's a question about what is the meaning of interoperability in relation to software.
Yeah, I mean, across languages is sometimes tricky, right? I mean, having that in all cases, no, but it's more about also, yeah, using standard data types, for example, because then if you, the one piece of software has an output in kind of a standard documented data format, this can be read in and processed by other software, whether in the same language or no, but then if it's clear what the data format is. If you start inventing your own output formats for the software, then it becomes more difficult, for example. Yeah, and if you develop like a Python library, for example, it's a good idea to stick to the standards of the Python ecosystem to make sure it's actually like integratable in the Python package index, these kind of things. Making it always like interoperable across languages can sometimes be tricky, but yeah, if the standardized data type might be the bridge already.
Maybe we have time for one last question. I'll read one last.
I really also need to leave on time.
To leave, okay. So maybe maybe we'll keep it at this. Yeah, thanks very much, everybody, for joining in. Thanks. I saw a few people already registered for the next webinar in September. We actually have we had the 3 speakers here at the very beginning. Thanks very much. It promises to be also a very interesting webinar. Thank you very much, Anna-Lena. It's been a wonderful presentation, interesting questions and discussion. Thank you, everybody. We will thank you for your questions, and again, apologies that we couldn't answer all of them
another time.
Yeah.